Hi, this is Ms. DB, and today we're going to look at some more theorems about isosceles and equilateral triangles. That's Chapter 4, Section 8. So in this section, we're going to start with a little bit of a warm-up to review these ideas. So for number 1, find each angle measure of that triangle, and then answer true or false for the next two. So for number 1, it's marked that all sides are congruent, therefore it's equilateral triangle. And you learned that in an equilateral triangle, if all the sides are congruent, all the angles are also congruent, and you already know that there's 180 degrees in a triangle. So to do the first one, you would take 180 divided by 3 and get that each of those angles are 60 degrees. That's going to be true for any equilateral triangle. Equiangular, equilateral triangles have 60-degree angles. Okay, number 2, every equilateral triangle is isosceles. Isosceles is defined as at least 2 sides are congruent. And an equilateral triangle is 3 sides are congruent. So therefore, number 2 is true. But number 3 says every isosceles triangle is equilateral, and that's not true. And you could draw a counterexample with 2 sides being congruent and the third side not being congruent. This is isosceles, but not equilateral. Our objectives today are to learn and use theorems about isosceles and equilateral triangles, and then to apply the properties of isosceles and equilateral triangles in order to solve problems. Usually you'll be finding a missing part to the triangle. Here's your vocabulary. You need to know what are the legs of the isosceles triangle, the vertex angle, again, of an isosceles triangle, the base and the base angles. All of these have to do with isosceles triangles. So in an isosceles triangle, is there a picture here? Yeah. In an isosceles triangle, there's at least 2 congruent sides. So in this one, they're marked with the congruent tick mark. So these 2 sides are congruent. The congruent sides are called the legs. So this is a leg, and this is a leg. The other side is called the base. Okay. The vertex angle is the angle formed by the legs. This is the vertex angle right here, angle 3. And the base angles are opposite the legs, so they hook the base and the leg together. Okay, so these are the base angles here. So in this picture, 1 and 2 are base angles, 3 is a vertex angle. And then we got the 2 legs are sides, and the base is the other side. That's not the congruent. And you need to know that because the theorems are worded with those kind of things in them sometimes. Okay, so, in our first theorem is the isosceles triangle theorem. These both have to do with the same thing. One's the converse. If 2 sides of a triangle are congruent, then the angles opposite the sides are congruent. So an easier way to say this is, in an isosceles triangle, base angles are congruent. In an isosceles triangle, the base angles are congruent. The converse says that if, so let's say if congruent sides, and in the converse of it, it says if base angles are congruent, then the sides are congruent. So in the first theorem, in isosceles triangle theorem, you start with given sides, and then you can say that the base angles are congruent. In the converse of it, you start with congruent angles, and then you can say, therefore, the sides will be congruent. So it just is depending which part you're starting with, which theorem you're going to use. And again, sometimes it's called base angles of an isosceles triangle are congruent, because that's really what it says. All right, let's see how we could use that. In this picture, we have a triangle. I'm going to redraw this triangle without the house. It's just the roof I want to worry about. This is X, Y, and Z. This is 20 feet. This is given as 40 degrees. And this over here is given as 140 degrees, the exterior angle there, from here to here. And they want us to explain why the length of YZ is the same as the length of XY or YX. Let's find this angle, the angle adjacent to the 140 degree. Let me use a different color here. This part right here plus the 140 has to make a straight line because they're a linear pair. So 180 minus 140 is 40 degrees. So base angles are equal. Base angles are equal. If the base angles are equal, then we know that the side lengths are the same. Do you remember why? It was the converse of the isosceles triangle theorem. If you're given, or if you can find that the base angles are congruent, then you know that the lengths of the sides opposite them are the same by the converse of the isosceles triangle theorem. Okay, here's another example. If the distance from Earth to a star in September is 4.2 times 10 to the 13th kilometer, what is the distance from Earth to the star in March? Well, this is kind of crazy, but there's 6 months between September and March. So the angle measures will be approximately the same between Earth and the star. So think about it this way. Here's our Earth. Here's the star. Whoa, I'm supposed to touch the Earth there. Here and here. Like here is September. This isn't exactly right, but and here's March. Okay, so we can think about that as being an isosceles triangle, with this being our base angles here. And if the base angles are congruent, because they're both they're 6 months apart, then these will be congruent. So the distance should be the same, which is 4.2 times 10 to the 13th. So if you can show it's an isosceles triangle, then you can say that the lengths are the same. All right, let's look at this example. In this one, we're just going to find the missing measure. This is more like what your problems will be on your worksheet. It says to find measure of angle F. And all I'm given is that angle E is 22 degrees. However, we know that it's an isosceles triangle, so we know that the base angles will be congruent. We also know there's 180 degrees in every triangle. So let's see what we have to work with. If we take 180 minus 22, I get 158. That means that these two angles together are 158. But they're the same. So I can just take 158 and I can divide it by 2 in order to figure out my answer. Now they write a nice little equation for this, but basically they're going to do the same thing. They're going to take 158 divided by 2 to get 79 degrees. That means angle D is 79 and angle F is 79, and that's what we were trying to find. So subtract the known angle from 180 if you're given the non-base angle, and then divide by 2. Okay, let's look at this one. This one, they want us to find the measure of angle G. We don't know this one at all. We don't need to know that one at all, because this is an isosceles triangle, so base angles are equal. So if you know base angles are equal, you're going to set up an equation that says they're equal. X plus 44 equals 3x. You don't need the parentheses there. It's just there to show that it's degrees. So we would subtract x from both sides and then divide by 2. And we get 22 for x. That's not what they asked us to find, though. They said, what's the measure of angle G? So then you put 22 back in. 22 plus 44 is 66. So that's what you're going to be doing. You're going to be finding missing angles and then some missing side lengths. Okay, try this one. It's an isosceles triangle. Base angles will be equal. We're given the vertex angle, so we could subtract that from 180. And then you could divide by 2 in order to find what each angle would be equal to. So angle H you should have found was 66 degrees. Here's another example. This time you're given expressions for each of the base angles. they're equal to each other, set them equal to each other, solve for y, plug y back in, and you find your measure of angle n. There's a corollary to the isosceles triangle theorem that says that if a triangle is equilateral, then it's equiangular. I've already kind of implied this before. But if you have an equilateral triangle, it's also going to be equiangular. So all the angles will be the same. And also, if it's equiangular, it's going to be equilateral. So if you know all the angles are the same, all the side lengths are the same. If you know all the side lengths are the same, all the angles are the same. So in this one, we know that every angle is going to be 2x plus 32, right? They're all 2x plus 32 because all the sides are the same. So in order to solve this, we also know that there's 180 degrees in a triangle, right? So that means that every one of these angles is 60 degrees. Now they ask us to find just the measure of x in this one. We don't have to find a certain angle. So all we have to do is write the expression that 2x plus 32 equals 60. And then we solve and we get the value of x. Now if they ask us to find angle L or angle K or angle M, we would just plug x back in here, and we'd have 2 times x, 2 times 14, and then we would know that it's 60 degrees, which is exactly what we should have got, so we can kind of check it as we go. So they're all 60 degrees, and x is, in this case, 14. Okay, here's one where you're going to find missing side lengths. How can we do this? We can do this by the corollary that says that if it's equiangular, it's also equilateral. So we know that 5y minus 6 is going to be equal to 4y plus 12. And then you can solve for y and find your missing y. All right, so now you're going to take do one on your own here. So we've got a triangle and it's marked equiangular. So see if you can find the value of side length JL. So you would say, well, if it's equiangular, it's also equilateral. So I can set those expressions equal to each other. Solve for t. Subtract 2t from both sides. Hey, there's a mistake in here. You would subtract 2t from both sides. And then you would add 8 to both sides. And you'd get 2t equals 9, and you get t equals 4.5. It's fine to get a decimal for an answer too. Don't worry about that. Now that you know what t is, you're going to take and plug it back in to side expression for side JL. And when you do that, you get 2 times 4.5 is 9, plus 1 is 10. Okay, that's it. It's not too bad of a lesson. You'll be finding missing angles and missing side lengths. Please let me know if you have any questions. I'm here to help, or come to my office hours. Thank you very much.